What does the butterfly effect mean in chaos theory? Have you ever heard of the butterfly effect? It is the idea that a very small change can lead to an enormous result over time. This idea often appears in time travel stories in movies and TV shows. For example, someone goes back to the past and changes one small action, only to return to a completely different world in the present. Can one tiny change really change the future? The expression butterfly effect was created by the American meteorologist Lorenz. He was conducting an experiment using a computer to predict the weather. One day, he entered a number slightly differently. Originally, he used the number 0.506127, but this time he shortened it and entered only 0.506. The difference was extremely small. However, over time, the computer's weather predictions became completely different. Why did this happen? Lorenz discovered that even a tiny difference can grow dramatically over time. In 1972, he gave a lecture titled, "Predictability: Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?" Of course, this does not mean that a single butterfly literally creates a tornado. It means that even a tiny change can have a huge effect over a long period of time. We can see similar examples around us. When a snowball rolls down a mountain, it starts small but gradually grows larger. A tiny spark can also grow into a massive wildfire. At first, the changes seem tiny, but over time, they can lead to enormous results. The butterfly effect works in the same way. Then why were scientists so interested in the butterfly effect? In the past, scientists tried to explain the movement of planets through mathematics. In particular, Isaac Newton explained the motion of two objects using the law of gravity. When there were only two objects, like the Sun and Earth, the calculations worked well. However, when a third object was added, the problem became much more difficult. This was because the motion became extremely complex when three objects pulled on one another. This is called the three-body problem. Why did adding just one more object make the calculations so difficult? It was because there were far too many interactions affecting one another. The French mathematician Poincaré discovered something important while studying this problem. At first, the differences were extremely small, but over time, the results became completely different. Poincaré realized that nature contains phenomena that are highly sensitive to small changes. This became the beginning of chaos theory. Does this mean the weather can never be predicted accurately? In fact, the weather contains too many factors. Temperature, wind, humidity, and air pressure constantly affect one another. As a result, even a tiny difference can greatly change the outcome. Still, scientists did not give up on prediction. Scientists use probability and statistics. One scientist who used this approach was Ludwig Boltzmann. Instead of calculating the movement of countless gas molecules one by one, he tried to explain them using averages and probabilities. In other words, even if we cannot calculate the movement of every single molecule, we can still predict the overall behavior of the system. Weather forecasts work in a similar way. It is difficult to predict tomorrow's weather with 100% accuracy. However, by using statistics and computer calculations, scientists can estimate whether rain is likely or whether the temperature will rise. That is why we check the weather forecast to decide whether to bring an umbrella or choose what to wear. Think about it yourselves. What kind of changes might one small action today create in the future? One small act of kindness might make someone happy, and one small effort might lead to great success. The butterfly effect in chaos theory teaches us that even the smallest change may not be small at all.